In this lesson, we're going to learn about arithmetic sequences. Sequences are a set of numbers in a specific order. And when we look at arithmetic sequences specifically, we look at from one term to the next or from one number to the next, there is a common difference, or that the difference between them is constant. So if we look at example 1, for example, we can look and say our sequence of 1, 3, 5, 7, 9, 11, it's quite clear to say, hey, to get from 1 to 3 or 3 to 5 or 5 to 7, I'm going to add 2 every time. Right? We have that common difference, we call that. So we can say, because that common difference is the same no matter where we look within our sequence, that has a common difference of 2. In example 2, we can say the same thing. We can say 12, 15, 18, 21. I'm adding 3 every time to get there. So my common difference would be 3. And because that's my constant common difference, it's an arithmetic sequence. So we can see right here down below these examples that the definition of an arithmetic sequence is written out here, right? That it's a numerical pattern increasing or decreasing at a constant rate, because it's okay to go up or down by that common difference, because we can add or subtract, or we can talk about adding a positive or adding a negative number. We can write our terms of an arithmetic sequence. We write our terms with subscript. So A sub 1 means we're talking about the first term. Our common difference we call our D value, D for difference, right? And then finally, our explicit formula for an arithmetic sequence is given here, where we can say that any term n, right? That's what this n here means, any term or our nth term, can be determined by saying, I'm going to take my common difference, or excuse me, I'm going to take my first term, A sub 1, right? Plus n minus 1, where again, n is our term number that we're talking about with the nth term from before, times our common difference. So what does this mean? Well, if we write out the numbers we had back in example 1 a little bit more spaced out, 1, 3, 5, 7, and I think that's all we need for now. We can take a look at this and say, look, all right, from our first term, since we're talking about our first term down here in our explicit formula, from our first term of 1, how do I get to 3? I add my common difference of 2 once, right? So I've added that 2 one time. From our first term, how do I get to my third term? Well, I add my common difference once and then twice. So I've added 2 times. How do I get from my first term to my fourth term? I add my common difference once, twice, and 3 times. So I've added a third time. So let's go back quickly and review that. To get to my second term, I add it once. To get to my third term, I add it twice. To get to my fourth term, I add it 3 times. So the number of times we're adding our common difference is 1 less than our term number. 1 less than our term number would be this n minus 1 down here in the explicit formula, right? Our term number is n, subtract 1, that's 1 less, times the number of common differences. We'll get some practice with that here, but first let's determine whether a sequence is arithmetic or not. So what we have to check is there a common difference? So how do I get from 1 to 5? I add 4. From 5 to 9, I add 4. 9 to 13, I add 4. And I have to check the whole thing because I need to make sure that that common difference is constant. So is this arithmetic here? Yes, there's a common difference of positive 4. In 2, how do I get from 8 to 4? I subtract 4. Subtract 4, subtract 4, and subtract 4. So it's constant the whole time. So yes, this is still arithmetic. There's a common difference of negative 4. Let's go down to 4 here. It says find the next 3 terms of the arithmetic sequence. So it tells us it already is an arithmetic sequence. So I can say, hey, just looking here, that means my common difference is equal to 4. So to find my next 3 terms, all I need to do is take my common difference now to the last known term, 25, add 4, I get 29. Add 4, we get 33. Add 4, we get 37. Let's do it again here in 5. Again, it told us it was an arithmetic sequence, so I know for a fact there should be a common difference. How do I get from 4 to 0? I have to subtract 4, so there's my common difference. So to find the next 3 terms, I go to my last known term, negative 12, subtract 4, and keep doing so 3 times. Now here in 7, this is where it gets a little bit more tricky because it asks us to write the equation for the nth term. And our nth term was this explicit formula that we had before that we talked about, that a sub n is equal to a sub 1 plus n minus 1 times d. So to write it to find the nth term means I'm not actually going to have an n value. So what I need to determine, though, is two things. I need to determine what is my first term and what's my common difference. And the first term is relatively easy, right? That's visually, I look at my list of numbers and say, hey, my first term is the first number that pops up in my set. That's 1. Now my common difference, I have a little bit more work to do. It tells us again in the instructions that each of these are arithmetic sequences. So I'm saying, what am I adding or subtracting each time? I'm adding 2 each time. So there's my common difference. So now I'm plugging this in and I'm saying a sub n is equal to my first term we established was 1 plus n minus 1 times our common difference of 2. And this here is now a equation that can help us find the nth term of any sequence. So it didn't ask us to do it, but I just quickly want to go over this here. So now if I wanted to find the 100th term, right? Instead of me just adding 2 until I find it, if I want to find the 100th term, I can plug in n is equal to 100 because that means the 100th term. So I can say a sub 100, my 100th term is equal to the first term plus 100 minus 1 times 2. Right? We can simplify that into 1 plus 99 times 2. And this gives us 199, would be our 100th term of that sequence here. Okay, so that's why it's useful to have this explicit formula here, because if we know the first term and the common difference, then we can find any term n, we call it. So we do the same thing here. A sub n is equal to, hey, my first term is negative 1 plus n minus 1 times my common difference. Well, what do we get? How do we go from negative 1 to negative 4 or so forth from one term to the next? We subtract 3. There's my common difference, and there's my explicit formula. So my explicit formula helps me find any term that I want farther down the road. There's also another way to write these, and that's to write them recursively. A recursive formula is a formula that allows us to find the nth term of a sequence by performing operations on one or more of the terms that precede it. To precede it means the terms that come before it. So let's take a look at this right here and what this means here. So it tells us here that we have our first term is 5. Okay, and then it gives us a rule. It says, all right, to find your nth term, you take a sub n minus 1 plus 14, where a sub n minus 1 here, this piece means the term before it. Right? Because we're saying to find the nth term, take the nth term minus 1, so the term before it, and add 14. Okay? So it's actually decently simple once we know what it means in terms of the term before it, because we're going to do like the explicit workout for a couple of them, and then really we're going to write the rule and just go ahead with the rule and move forward from there. So what we mean is this. We're already given the first term. So for me to find the second term when n is 2, I can plug it into that highlighted green formula there. Sorry. We can plug it into the highlighted green formula and say a sub 2, so I'm plugging in 2 for n, is equal to a sub 2 minus 1 plus 14. Well, we can simplify a sub 2 minus 1 to just be a sub 1 plus 14. And what a sub 1 means is our first term, right? So we're saying our first term plus 14, and we know our first term is 5. So 5 plus 14, hey, that gives us 19. There's our next term. We need to find 3 more terms. So now if I want to find, hey, the third term, that's n is equal to 3. I'm going to plug n is equal to 3 into that formula. We get a sub 3 minus 1 plus 14. We can simplify 3 minus 1 to a sub 2 plus 14. And now we know what a sub 2 is. A sub 2 was that 19 from above. That means our second term. So we can say that's the 19 plus 14. This gives us 33. There's our next term. And we can continue that work, but really if we read this, what this rule is stating here, right, our AN rule is stating a sub n minus 1 is take the term before and add 14. So how do I find the fourth term because we have the first 3 now? Well, I take the term before, which would be the third term, and I add 14. How do I find the fifth term? I take the term before and I add 14. And there are my 5. So what does this piece mean here? Where it says where n is greater than or equal to 2, that's solely saying we use it to find the second term on. With a recursive formula, you have to be given the first term. All right, so let's try it again here in 10. It says find the first 5 terms of the sequence. We're given the first term, that's 8. Let's try to dissect what the rule is. Here, a sub n minus 1, so I'm going to write this out in an English sentence. A sub n means a sub n minus 1 is take the term before, and then we're subtracting 6. If you can dissect that, if what that means without needing to do all the math and plugging in, right, we can go here and say, all right, we have the first term. To find the second term, take the term before the first term, which is 8, subtract 6, we get 2. To find the third term, take the term before, subtract 6, we get -4. And I'm really just taking that each term and subtracting 6 to get from one to the next. Again, I can do it a little bit more formally. I don't have to, but if I was like, hey, to do it formally here with n is equal to 2, to find the second term, I plug into a sub n, I plug in 2 for n, I can get a sub 2 minus 1 minus 6. We can simplify 2 minus 1. And we know what a sub 1 is. We were given it. This is 8 minus 6. Hey, that's equal to 2. That's the very formal work. But we don't necessarily need that. So again, let's take a look at the rule here. A sub n minus 1 is now second. So when I'm writing this rule, I'm like, look, a sub n is equal to 13 plus the term before. We should know with commutative property, it doesn't matter if I add the 13 in the front or the back. That's not a big deal, but we were given -32 as our first term. If I add 13 to that, we get -19. Add 13, we get -6. Add 13, we get +7. Add 13, we get 20. That's really what we're doing from one to the next. So how do we write these things? Okay, so it's important that we're looking at what we were given here above in 10 and 11. How do we write them? We have to define a sub 1. What is our first term? Right? And then we define our rule. What's happening to the term before is what we're looking at when we talk about recursive. This recursive tells me I need a sub n minus 1. So I look at my rule and I'm saying from any of these terms, how do I get from one to the next? And I'm subtracting 6. So I take the term before, I subtract 6, there's my answer. In 15, same thing, recursive formula. I need to define my first term, and then I also then need to go and say, what's my rule on the term before? So I look at how do I get from -8 to -3, -3 to 2, from 2 to 7. Some of these, when you get to negative numbers, can be a little bit tricky. Pick the one that's easiest. To get from 2 to 7, I have to add 5. That's going to be the same rule all the way across. Hey, add 5 to the rule before.